Hey guys, tonight I wanted to talk to you about indexing plates. Here a shaft is set up in a Kurt style vise. An indexing plate is secured onto the shaft, and the end here has been milled six-sided, hexagonal for say a ratchet and socket arrangement, or it could be 6 spokes on a wheel, or 6 features evenly spaced around the shaft. Here's the hexagonal indexer plates here. The larger one has a 2-inch capacity. The smaller one has a 1-inch capacity. On this side here we have the octagonal or 8-sided indexer plates. These are just secured to the shaft using a set screw. Shaft sits in the bottom V groove, much like a lathe dog. Doesn't matter if the shaft is centered in this plate or not. It could be way off to one side or high or low, it doesn't matter. The square is used to index the plate, and as long as the sides are true to each other, you'll get your features spaced properly around the shaft. Degree corners. 1 1/16 is the actual capacity. I'm saying 1 inch, but it's actually 1 1/16, and a 1/4 inch hole in the crotch here. And it's from 3/8 plate. We will use a number 10 set screw, 1024. I've decided to show the 2-inch octagonal indexing plate. In this shot, a 3-inch square piece of 3/8 plate is just being squared up in the mill. This is the basis for our 2-inch octagonal indexing plate. Here the 45s have been laid out on the stock, and I'm using a portable bandsaw on a small table to trim off the corners close to the scribe marks so that the not so much milling. So here the rough cut that we just made is upmost in the vise here. We're using a protractor to ensure that the original face of the square stock is exactly 45 degrees to the mill table. Using a protractor for this. The little clamp on the left hand side of the rule is just there for staging purposes, for staging the photo. So now, with our work set up this way in the vise, we can skim down, we can face that top down to the scribe marks. Here the blank is in another orientation. The face on the bottom of the jaws has been completed, so now we can use that as a parallel surface for where we want to mill. We can just simply place it in the vise on the bottom of the jaws and clean up our rough cut on the top face. Here's another setup. The face against the 1, 2, 3 block has been finished, so that presents the top face at exactly 90 degrees to the 1, 2, 3 block. The rough cut can be milled nice and flat. Okay, in this shot the exterior sides have been milled. The center marks for the two holes have been laid out. The upper hole will end up at 2 1/16 and the lower hole will end up at 1/4 inch. Here the bottom 1/4 inch hole has been drilled, and we're using an annular cutter to remove the majority of the material on the large upper hole. It will end up at 2 1/16. I think the annular cutter I used was 1 3/4. Okay, we've moved the work to the lathe. The 8-sided indexing plate, of course, fits nicely in a four-jaw chuck. The hole is not in the center of the stock, so the work's been offset in the 4-jaw. It's a quick matter of boring from this point on. Okay, here the 2 1/16 hole has been completed, and we are milling between the 1/4 inch and the 2 1/16 hole. It's interesting that the setup shown here, grasping the two sides of the indexing plate, allow you to complete all the milling in one setup. The X and the Y are both set up for blending the two holes. Here we found the center of the top face and are drilling and tapping 1024 for the set screw. Okay, here is our completed indexing plate in use. Suppose we had to place 8 features equally spaced around the perimeter of this shaft. We simply install the indexing plate on the shaft with the set screw. Put some packing under the set screw if it's going to mar your finish, of course, if that's important. The indexing plate is installed. The square is being used to present that face of the work perpendicular to the mill table. The vise has been closed. There's no cutting forces whatsoever on the indexing plate. It's simply there as a tool for positioning. We're all set up here. We can mill, rotate, align, mill, rotate, align, etc. all the way around. Okay guys, here is the indexing plate used in what I will call drill press mode. The work is sitting vertically in the vise. There's a V-block behind the shaft. The V-block is up against a stop on the left-hand side so that the center line of the work is always at the same point relative to the spindle. The indexing plate has been installed on the shaft, and there's a square on the left-hand side used to index the shaft around. As you can see on the top, you can equally space either 2, 4, or 8 features around the shaft. There you have it, guys. A fun few hours in the shop, providing a useful tool that you can use for the rest of your days. This tool will outlive you. I'm going to make available a set of drawings for these indexing plates. I'll put them up as a digital download on at my store. The link to the store is in the description. I'm going to try and keep the price to $4 US. It's a simple project. The drawings, it'll be drawings, build notes, and examples of use, basically going over what we've seen here tonight, but a complete dimension drawings. I should be able to get these out on February 22nd, probably it would be late in the evening by the time they come up on the store. But be sure and stop by the store anyway, check out the machinist clamp kits, and get yourself a digital download of these drawings if you'd like. Thanks for watching, guys.